Thank you. Good morning, dear students. In this session, I'll be talking about what is the position time graph for stationary object uniform motion, which is called XT graph, position time graph. In bracket, it is called XT graph. So whenever an object changes its position with time, motion is a change in position with respect to time. Motion is defined as an object moves from one point to the other point with respect to time. It is called motion. So when an object is at rest, I need to put it graphically. The graphical presentation or representation is called XT graph. X is a position. It talks about X coordinate, that is X axis, and T stands for time. Means two physical quantities. X is a position parameter which gives me path length or a displacement. This chapter is concerned about motion in a straight line. Means an object is restricted to move along a particular direction. When it moves along a particular direction, what happens to XT graph? XT graph means only the object is moving along a particular direction. That direction is called the X-axis, and position coordinates are taken in terms of X-axis. That's why XT graph. XT means X talks about position, T talks about time. So when I talk about a stationary object, take an example stationary object. In front of your home, you have a car which is parked. Take at 8 a.m., time is 8 a.m., that is the starting time. 8 a.m., the car is in front of your home. 9 a.m. also same thing, 10 a.m. same thing, everything. Till evening 5 p.m., you check your car is rest. Means it is not made to move. So it is stationary now. I can say it is standing still. The words are similar words. I can say the car is rest, car is stationary, car is standing still since morning 8 a.m. to evening 5 p.m. How to represent it in a graph? It is called XT graph. Let me have a small diagram. This is called time axis, measured in second. This is called position. X is measured in meter. I think everything is clearly visible. So once I say stationary object, what it means, any time interval you take, morning 8 a.m. to 5 a.m. or morning 6 a.m. to evening 6 a.m. or 6 p.m., what you take, the object is stationary. How to represent it? Take, for example, this is your x-axis, 10 meter, 20 meter, 30 meter, 40 meter. Book has taken some reference marker, 40 meter. Means your home is taken as a reference point, and with respect to your home, it is at a distance 40 meter, and at 40 meter it is rest. And time is, instead of taking 0 second, I can say 8 a.m. So instead of taking 8 a.m., we will take it as a 0 second, 10 second, 20 second, 30 second, 40, 50, 60, 70. So you go with 50 second or 60 second, whatever time interval you talk, it is in second. I hope you are getting a point. Car is parked in front of your home. With respect to your home, home is taken as a 0. So it is parked. So if I measure a distance, take it is at 40 meter. Book diagram I am supporting. So the car is here. At 10 second, it is detected here. So since morning to evening, it is located here only at 10 second, 20 second, 30 second, 40 second, 50 second, something like you go on putting. Now when I join all these things, all this dotted line, it looks like a straight line. So then I can say, now XT graph for stationary object is parallel to time axis. This is called XT graph parallel to time axis. And slope, what is slope? Slope is a mathematical parameter. It is dimensionless. Of course, here it is a parameter. It is position upon time, which give you velocity. Later we'll discuss. Now, y, this is called, normally, generally it is y-axis, this is x-axis. Along x-axis, I have taken time. Along y-axis, I have taken position coordinate. Slope is defined as dy, delta y by delta x, change in y coordinate to change in x coordinate. Now, slope here, since position, so slope mathematically is written as change in position to change in time. This delta x, so for 10 second also, it is here, and this x never changes. I can say x is constant. What is this? This graph indicates when it's straight line, x value is constant. When x value is constant, change in x is 0. Of course, time is changing, but when time is changing, it is not 0. You can say 30 seconds, whatever you write, but finally your answer is slope is 0. Do remember, whenever you have a xt graph, if this is, it is called position time graph. If this line is parallel to time axis, slope is 0. Means this variable position is not changing. Not changing means it's a constant. When there is no change, it is taken as 0. Hence, the slope becomes 0. So when an object is stationary, the graph is this. This is called xt graph. Now, similarly, we'll go for uniform motion. The second one I will take up. Let me have a small diagram. Again, time axis measured in second. Again, position measured in terms of meter. Now, what is uniform motion? Do remember, motion is a change in a position of an object with time, motion. So I am written uniform motion. What is uniform? Means equal distances in equal interval of time. If object covers equal distances in equal intervals of time, I will be writing here equal distance in equal time intervals. Such motion is called uniform motion. What is uniform motion? Uniform motion is defined as when an object covers equal distances in equal intervals of time. And how we put it? Take for example, x equal to 0, because this is x-axis, 0, 10, 20, 30, 40, 50, 60 meters. So similarly, I have 10 second, 20 second, 30 second, 40 second, 50 second, 70 seconds. In that, for 10 second, it is 10 meter. So 20 second, it is here again. So if I get points like 10 second, 10 meter, 20 second, 20 meter, 30 second, 30 meter, 40 second, 40, means it is going to cover equal distance in equal intervals of time. So finally, I'm going to get a graph like this. So this graph, if you cross check, yes, let me have a graph. It has a slope whose slope is again defined as delta x upon delta t. This is changing equal distance in equal interval of time. Example, 10 upon 10 or 20 upon 20 or 30 upon 30 or anything. It is going to be a constant. Slope is constant. What is constant here? Because it becomes finally 1, 30 by 31, 20 by 21. So what I mean to say, slope is constant. When slope is constant, it is called uniform motion. What is uniform motion? Uniform motion means when an object covers equal distances in equal intervals of time, the graph looks like this. If you go for a slope for it, delta x upon delta t, delta x will equal 10 by 10, 10 meter by 10 second, 20 meter by 20 second, 30 meter by 30 second. This is called constant. It is going to be a 1. 1 or 8 maybe anything. Or you can write it at 15 by 5. So you can have this ratio also. I hope there is a place. Yes, 15 by 5. Or you can say 30 by 10. Check this ratio. 15 by 5 is 3. 3. Everywhere it remains. It is not 1. It can be 2. It can be 3. Means that ratio is going to be constant. What I mean to say, uniform motion is a motion in which object covers equal distances in equal interval of time. This is a beautiful graph. Yes, once again I will explain. This is called position time graph for motion of a car. Consider a car which is at rest at x equal to 0 when time is 0. It starts from rest and initially up to 10 second. From 0 second to 10 second, it speeds up. Where if I measure the slope will not be a constant, means it is changing. Slope will not be a constant, means it is changing. From 10 seconds up to 18 seconds, the car moves with uniform motion in this region. From 10 seconds up to this region, this curve is called uniform motion line. So where if I take a slope here, here, anywhere on this particular curve, the slope is constant. Constant slope means uniform motion. Uniform motion means the car covers equal distances in equal intervals of time between this interval, that is 10 seconds to 18. At 18 seconds, the brakes are applied to the car comes to stop at the 20th second. This is called position time, means I am representing the motion of a car in terms of position time graph. It looks like this. Speeds up, uniform motion, brakes are applied.